Listen to me closely. I want you to close your eyes and imagine the unthinkable. Imagine that tomorrow morning you wake up and the world has gone silent. A cataclysm, a catastrophe, some terrible event has wiped out everything we have built. The servers are melted, the libraries are burned, the great cathedrals of science and art are reduced to dust. Civilization is reset to zero. You are standing in the ruins, the wind howling through the twisted steel. You realize you have only one moment, one breath, to pass a single message to the next generation of survivors. You cannot teach them calculus. You cannot explain the internal combustion engine or the history of the Roman Empire. You have time for one single sentence, one statement to encapsulate the most important knowledge we possess. What do you say? Do you tell them about God? Do you tell them that the square of the hypotenuse is equal to the sum of the squares of the other two sides? Number that is useless to a man trying to purify water or forge steel. If I were standing in that rubble, I would tell them this. All things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. That is it. That is the sentence. You might think, Richard, that sounds simple. That sounds obvious. But you are wrong. In that one sentence, if you use just a little bit of imagination and a little bit of thinking, you will find an enormous amount of information about the world. It is the key to the library of the universe. But to use it, you have to stop looking at the world with your eyes and start looking with your mind. You have to shatter the illusion of the smooth, static world you think you live in. Let's talk about that illusion. When you look at a glass of water or a block of ice or even the back of your own hand, what do you see? You see something still. You see something solid. You see stuff. It sits there, quiet and obedient. This is a lie. This is a deception created by the low resolution of your biological sensors. Your eyes are too crude to see the truth. If you cling to this idea that matter is static, that a stone is just a stone, sitting there doing nothing, you will never understand how the universe works. You need to delete the picture in your head of the solar system, those neat little electrons, orbiting a nucleus like planets. That is a cartoon. That is wrong. It is too polite. I want you to replace that image with something else. I want you to imagine a mosh pit. I want you to imagine a swarm of bees, terrified and angry. I want you to imagine billions and billions of tiny balls, shifting, banging, clattering, and vibrating. Nothing is ever still. Even in the coldest stone on the darkest planet, the atoms are jiggling. They are shivering. The universe is a riot of motion. This is the first thing you must understand. Nature is not static. Nature is a dynamic, chaotic storm that never sleeps. Now, let's try an experiment. You don't need a microscope. You need your imagination. Look at a drop of water, just a single drop, 1/4 of an inch across. To you, it looks like a clear, smooth gem. But let's zoom in. Let's magnify it 1 billion times until that drop is 15 miles across. What do you see now? You don't see water. You see a crowd. You see something that looks like a football stadium times 1,000,000, filled with energetic, frantic little shapes. These are the water molecules, 1 oxygen, 2 hydrogens, sticking together like little Mickey Mouse heads. And they are not sitting in their seats. They are moving. They are crashing into each other, twisting, turning, vibrating. It is a seething mass of violence. But wait, look closer. Why are they sticking together? Why don't they just fly apart? This brings us to the first part of our magic sentence, attracting each other when they are a little distance apart. There is a force, a longing, a magnetic pull that makes them want to be near their neighbors. They are sticky. They want to clump. This is why water forms a puddle. This is why it doesn't just explode into mist instantly. But watch what happens when 2 of them crash head-on. Do they pass through each other? Number, they bounce. Bang! They hit a wall. This is the second part of the sentence, repelling upon being squeezed into one another. They have personal space. They are impenetrable. So you have this eternal conflict, a desire to be close, but a refusal to overlap. Attraction and repulsion. This push and pull is the heartbeat of matter. Now, let's play God with this system. Let's talk about temperature. What is heat? Is it a fluid? Is it a ghost? Number heat is just motion. That is it. It is the jiggling. If I heat up this drop of water, what am I doing? I am kicking the molecules. I am making them move faster. I am increasing the chaos. Imagine the crowd in the stadium starts running, panicking. The attraction, the stickiness, is still there, trying to hold them together, but the speed is getting too high. Suddenly, one molecule gets hit hard whack, and it flies right out of the pile into the air. Another one follows, and another. The crowd is breaking apart. The attraction can't hold the speed. The water is boiling. It is becoming steam. Steam is just water molecules that are lonely, flying free, smashing into the walls of the container, desperate and isolated. Now, let's go the other way. Let's take the heat away. Let's calm them down. The jiggling slows. The motion decreases. The attraction starts to win. The molecules settle down. They find their places. They lock arms. They arrange themselves into a beautiful, rigid, hexagonal pattern. They are still vibrating, remember. Nothing ever stops, but they are vibrating in place, like soldiers shivering in formation. We call this ice. It is hard. Why? Because to push your finger through it, you have to break those locked arms. You have to break the structure. You can't just push them aside like you can in liquid water. All of these states, solid, liquid, gas, they are just a war between the energy of motion and the stickiness of attraction. It is a trade-off. It is a balance of power. Let's push this further. Think about the surface of the water. This is where it gets interesting. Look at the molecules on the very top layer. They have friends below them, pulling them down, but they have no friends above them. There is only the empty air, so they are being dragged inward, pulled tight against the crowd. This creates a skin, a tension. You've seen this. You've seen a bug walk on water. It is not magic. It is the atoms on the surface holding hands so tightly to avoid the loneliness of the air that they form a trampoline. The bug is walking on a molecular alliance. But the air isn't empty, is it? It is full of other atoms, nitrogen, oxygen, bombarding the surface. It is a war zone. The air molecules are hitting the water, and the water molecules are hitting the air. Sometimes a water molecule gets hit so hard, it gets knocked out of the water, evaporation. Sometimes an air molecule crashes into the water and gets stuck, dissolved air. It is a constant exchange, a dynamic equilibrium. Even in a glass of water sitting perfectly still on a table, there is a furious exchange of hostages happening at the surface every billionth of a second. Your eyes see peace. Reality is a battlefield. Now, I want to address something that confuses people, the direction of time, the flow of things. Let's take a drop of blue dye and put it in the water. Slowly, the blue spreads. Eventually, the whole glass is pale blue. Why? Why doesn't the blue dye ever gather back into a drop? The atoms don't know which way is forward in time. They just bounce. They are blind. So why does the world seem to have a direction? Why does the coffee cool down? Why does the egg break but never unbreak? This is where we have to talk about probability. It is simply a numbers game. There are billions of ways for the blue atoms to be scattered all over the glass. There is only one way for them to be gathered in a tiny drop. The atoms are wandering randomly. They are shaking and bumping. It is overwhelmingly probable that they will wander into a messy, scattered state, and overwhelmingly improbable that they will accidentally stumble back into a neat little pile. We call this entropy. We call this the arrow of time. But really, it is just the atoms shuffling the deck. The universe loves disorder, not because it is evil, but because there are simply more ways to be messy than there are to be tidy. You are seeing the triumph of statistics over structure. Let's go deeper. Let's talk about simultaneous events. You think there is a now. You think that what is happening right here is happening at the same time as something on Mars. But in this atomic dance, Everything is relative to the motion. But let's stick to the chemistry for a moment. Think about salt, a crystal of salt, a cube, rigid order. You drop it in the water. What happens? The water molecules, remember, they are charged. They have a positive side and a negative side. They see the salt. They swarm it. The negative oxygen sides surround the positive sodium atoms. The positive hydrogen sides surround the negative chlorine atoms. They pull, they tug, they carry the salt atoms away into the void. The crystal disappears. But is it gone? Number? The atoms are just floating, surrounded by water guards. If you evaporate the water, the guards leave and the salt atoms find each other again. Click, snap. The crystal returns. Nothing is destroyed. The actors just changed costumes. And what about fire? What about the burning of wood? This is the most beautiful violence of all. Wood is made of carbon and hydrogen, holding hands. Oxygen is in the air, floating by. They want to be together. Oxygen loves carbon, but they can't get close enough because the wood is cold. The atoms are moving too slow to overcome the repulsion barrier. But if you start it, if you light a match, you give them a kick, you push them over the hill. Snap! The carbon hits the oxygen. They bind. This snapping together releases energy. It is like a mousetrap going off. That energy hits the next atom, making it move faster, making it hit the next oxygen. A chain reaction, a cascade of molecular snapping. That kinetic energy, that furious jiggling caused by the marriage of carbon and oxygen, is what you feel as heat. That is fire. Fire is just the release of potential energy into kinetic chaos. Now, here is the part that might make you uncomfortable. I want you to look at yourself. Look at your hand again. Pinch your skin. Feel the warmth. What are you? You are not separate from this. You are not an observer standing outside the tank looking in. You are the tank. You are a pile of atoms. A very specific, very complex, very unstable pile of atoms. You are made of the same stuff as the water, the stone, the air, and the stars. The carbon in your muscles was forged in the heart of a dying star. The iron in your blood came from a supernova. But you are a special kind of pile. You are a pile that has learned to keep itself together. Your biology, your DNA, is a mechanism, a tiny molecular machine that takes in other atoms, food, strips them for parts, and uses them to repair your own structure. You are a continuous flow. The atoms in your brain today are not the same atoms that were there last year. You are like a wave in the ocean. The water changes, but the waveform persists. You are a pattern of atoms that has become complex enough to ask the question, what am I? This brings us to a strange philosophical precipice. If everything is just atoms bouncing by the laws of physics, attraction, repulsion, then where is you? Where is your free will? Is your thought just a chemical reaction? Is your love just a release of dopamine molecules? In a way, yes, but that doesn't make it less real. It makes it more miraculous. It means that out of the blind, chaotic, mindless jiggling of the universe, something emerged that can feel, that can wonder, that can cry. The universe has woken up. You are the universe looking at itself. We struggle to understand this because our brains were not built for this scale. We are giants. We live in a world of gravity and friction, not a world of electrostatic repulsion and thermal jitter. We try to use words like touch or solid or color, but those words don't apply down there. An atom has no color. An atom is mostly empty space. When you touch the table, you aren't touching it. Your electron clouds are pushing against its electron clouds. You are hovering on a cushion of force fields. We are trying to translate the language of the quantum world into the language of monkeys on a savanna. It is a translation problem. That is why it feels weird. That is why it feels counterintuitive. If you aren't confused, you aren't paying attention. So, let's go back to the rubble. Let's go back to that end of the world scenario. Why did I choose that sentence? All things are made of atoms. Why? Because once you know that matter has parts, once you know it follows rules, you can predict it. You can manipulate it. You can understand it. You stop praying to the lightning and start building lightning rod. You stop fearing the plague and start looking for the germ. The atomic hypothesis is the declaration that the world is knowable. It is not magic, it is a mechanism. And we have the blueprints. If you leave the survivors with that one sentence, they can derive the rest. They can figure out pressure, they can figure out heat, they can figure out chemistry, and eventually they can figure out life. They can rebuild. But more importantly, they will know our greatest secret, that we are all connected, quite literally, by the cosmic dust from which we are made. You are a collection of atoms that has paused its chaotic journey for a brief moment to form, you, before scattering back into the wind to become the grass, the ocean, and the stars. And that, my friends, is not a depressing thought. That is a glorious one. It means you are part of the play. You are not the audience. You are the show.